The story of the X-33 and VentureStar is one of the most ambitious, intriguing, and ultimately heartbreaking chapters in the history of spaceflight. It was NASA's bold attempt in the 1990s to replace the space shuttle with a fully reusable spaceplane, a single stage-to-orbit system that could dramatically cut launch costs and make space as accessible as commercial air travel. Although the program never reached completion, the design itself, the futuristic shapes of the X-33 test vehicle and its proposed VentureStar successor, still captures imaginations today. To understand what this rocket spaceplane hybrid really was, we'll take a deep look into its exterior design, the proposed interior environment, its performance goals, and even its costs and pricing story, which became a major factor in its cancellation. From the outside, the X-33 looked unlike any rocket NASA had ever flown. Instead of a tall cylindrical booster, it resembled a wedge-shaped lifting body with short delta wings and a sharply pointed nose. The design was optimized for aerodynamic lift during ascent and controlled gliding on return, eliminating the need for external boosters or fuel tanks like the shuttle relied on. Its structure was dominated by two massive propellant tanks inside, a liquid hydrogen tank and a liquid oxygen tank, feeding the revolutionary aerospike engines at the rear. Unlike conventional bell-shaped rocket engines, the aerospike nozzle was flat and linear, designed to maintain efficiency at different altitudes by allowing exhaust gases to expand naturally against the atmosphere. The rear of the vehicle was fitted with two linear aerospike engines, each stretching along the base, producing a combined thrust of over 200,000 pounds. Unlike traditional rockets, the engines did not look like deep, conical bells, but more like long, ridged exhaust trenches, giving the X-33 a futuristic and almost science fiction-like appearance. In terms of dimensions, the X-33 prototype was about 69 feet long and 77 feet wide, roughly half the size of the full VentureStar vehicle that was intended to follow. The VentureStar, had it been built, would have stood about 127 feet tall, larger than a Boeing 747 but still compact compared to the Space Shuttle stack with its boosters and external tank. Its exterior finish combined lightweight composite materials, including an advanced metallic thermal protection system. Instead of thousands of fragile black tiles like the shuttle used, VentureStar was designed with metallic shingles that could better withstand re-entry heating while requiring less maintenance. This was crucial. NASA and Lockheed Martin wanted a vehicle that could be turned around in 2 weeks or less between flights, unlike the shuttle, which often needed months of inspection and repair. Inside, the X-33 was an uncrewed test vehicle, so there was no astronaut cabin. However, its successor, the VentureStar, was envisioned to have a fully outfitted crew cabin at the forward end, similar in concept to a commercial jetliner. The interior of the VentureStar would have housed a cockpit for up to 4 crew members, with large forward-facing windows and advanced avionics displays. Behind the cockpit, the pressurized crew cabin was designed to carry between 4 and 7 astronauts, or potentially passengers in commercial spaceflight scenarios. The cargo bay was another key element of the VentureStar's interior layout. Located mid-fuselage, it would have provided volume for satellites, supplies for the International Space Station, or other payloads. The design included a clamshell-style payload bay door system similar to the shuttle's, but lighter and simpler. For uncrewed missions, the VentureStar could have flown entirely autonomously, with its cockpit and crew cabin empty. This was a major step forward in flexibility, as it combined the shuttle's human carrying capacity with the simplicity of automated cargo launches like today's SpaceX Dragon. The proposed interior systems were meant to be simpler and safer than the shuttle's. For example, there were no solid rocket boosters, so there was less vibration and fewer failure modes. The vehicle's aerospike engines were designed to throttle smoothly and safely from takeoff to orbit. Inside, astronauts would have experienced less noise and a smoother ride compared to the harsh, vibrating liftoff of the shuttle's twin solids. Performance was where the X-33 and VentureStar promised to change the world. Unlike conventional rockets, which discarded stages along the way, the VentureStar was envisioned as a single stage-to-orbit (SSTO) vehicle. That meant it would launch vertically like a rocket, reach orbit in one continuous ascent, and then glide back like a plane to land on a runway. The projected performance numbers were extraordinary. The VentureStar was designed to deliver up to 20,000 kilograms, 44,000 pounds, of payload into low Earth orbit. While this was less than the shuttle's maximum payload of 27,500 kilograms, VentureStar was intended to fly much more frequently and cheaply. The key to performance was the linear aerospike engine. Traditional Bell nozzles are efficient only at specific altitudes, but aerospike engines maintain efficiency across a wide range of atmospheric pressures. This meant VentureStar could carry less propellant and still reach orbit. The engines were designed to produce nearly 1.1 million pounds of thrust in total on the full VentureStar, more than enough to push the streamlined lifting body to orbital velocity. Reusability was another critical performance factor. Where the shuttle required a standing army of engineers to inspect and replace tiles, boosters, and main engines after every flight, VentureStar was envisioned to be far more aircraft-like in operations. Land it, inspect it, refuel it, and launch again within days or weeks. The turnaround time goal was revolutionary. NASA estimated that VentureStar could reduce the cost of putting a pound of payload into orbit from over $10,000 per pound with the shuttle down to as little as $1,000 per pound. If achieved, this would have transformed the economics of spaceflight and opened the door to commercial opportunities long before SpaceX or Blue Origin came along. But when we talk about cost, this is where the X-33/VentureStar story begins to unravel. The X-33 was awarded to Lockheed Martin in 1996 as part of NASA's Reusable Launch Vehicle (RLV) program. NASA invested about $912 million into the project, while Lockheed was supposed to contribute another $357 million. The total program cost was projected at $1.3 billion for the prototype. However, as development continued, problems began to pile up. The most significant issue was the composite liquid hydrogen fuel tank. Engineers struggled to create a lightweight yet strong composite structure that could handle the extreme cold and high pressures of liquid hydrogen. Cracks and leaks appeared during testing, and despite repeated redesigns, the tank never performed as required. Without a working tank, the X-33 couldn't fly. By 2001, after 5 years of delays and ballooning costs, NASA officially canceled the program. Estimates suggested that completing the full VentureStar system would have required at least $10 billion more, money that Congress was not willing to spend given the shuttle was still flying and the International SP. Third, it proved that NASA and industry were already thinking about the kinds of fully reusable, quick turnaround systems that companies like SpaceX and Blue Origin are now making real. In many ways, VentureStar was SpaceX before SpaceX. Finally, the cancellation of the program taught NASA a hard lesson about the risks of betting too heavily on unproven technology. By the early 2000s, attention shifted back to safer, incremental improvements, eventually leading to the Orion spacecraft and today's Artemis program. In the end, the X-33 never flew, and the VentureStar never left the drawing board. But their futuristic wedge-shaped design, their promise of fully reusable space travel, and their audacious vision still resonate with space fans and engineers alike. If it had succeeded, the X-33 might have changed the course of space history. Launch costs could have dropped dramatically, space stations might have become routine destinations, and perhaps even Mars missions would have been closer to reality. Instead, it remains a fascinating what-if, a bold experiment that showed both the possibilities and the pitfalls of pushing technology too far, too fast. The X-33 and VentureStar remain among the most iconic unflown spacecraft in history, a reminder that even failure can inspire future innovation. Their story is not just about what was lost, but about the seeds of ideas that are now bearing fruit in the reusable rockets and spaceplanes of today.